So today I thought we'd look at something pretty obscure, and I've never seen inside one of these. I've not seen inside this one, and it's the Eurocomm Euro 40. So let's see. Especially if I could spell. That one. So I bought it for £6 off eBay. We don't know anything about them, but I do know a little bit more than this, because I've done a scan of Citizens Band magazine for February 1983, which I'll just show you. Australia for £69. Let's just see if we can just zoom in on that. And it says that the distributor is Eurocomm Electronics. Eurocomm Electronics are a two-way radio organisation who are still in existence. And when I was manager at Nottingham Radio for all those years, in the 80s and 90s, I went to Eurocomm one day, and this would be about 18 months after this came out. And I went into reception. A lady came to see me, said, I want to discuss the Citizens Band radio you do, the Eurocomm DX40, whatever it is. She said, we've got nothing to do with CB whatsoever. So that was the end of that. So much for getting any information. Anyway, we'll go over to the workshop and we'll see if we can sort it out. It won't take much going in because I'll show you the front properly. So we've got, what on and off? Is that on and off? It says off volume. PA in squelch. That says on and off. 919 or normal, high and low. TX and busy light. And on the back, which is a fibre board, we've got a half decent type of fuse holder and a 2.5mm jack socket for extension speaker and for PA. So we're going to be having to play with the crocodile clips because we're just not set up for that. And it's serial number 233. Unfortunately, when I look inside it, the audio chip is missing, which should be down there, and it's no doubt supposed to be bolted to a heatsink, which is down there. And just to make matters worse, it's actually been ripped out. What it does say there is CB PCB. Oh dear, so this might end up being a show and tell rather than us actually doing anything with it. What we can do, you see, look at all this. There's a rat's nest of bodgy wires. Somebody's ruined the printed circuit and then put wires in to try and jump to it, no doubt unsuccessfully. Yeah, well, I'll just start by having a look through my files to see whether there's anything we can find on it. mean, I'd expect that's a TA7205, but without its heatsink, we're not going to be able to fit that. Tell you what we will do. We'll see if it lights up. And I'll just make sure before I do this that there's nothing shorting out. No, I can't turn it off, it's on. So at the moment, on and off is doing nothing, and there isn't a switch on volume. Right. Fascinating. Good news. I found we've got another one. This one with a bashed in meter and serial number 96. We'll open this one, and this comes with a mic as well. So I'll open this one up because this one is screwed together, and we will see whether this one's complete. Right, well, the good news is that that meter goes back quite easily, but I think we'll put a bit of hot glue on its little plastic support that you can very easily push it in, and it does switch on and off with the switch on this one. And we've got some kind of sound, and we've got some kind of transmit power as well. So I'll just do myself a little diagram, and I'll see if I can find my way around this very obscure radio. So I've done myself a little chart. I'll colour this in later when I've proved that I'm in the right direction. So we've got a LC7137 synthesizer. The reference crystal's 10.24 is usual for that, but there's no trimmer capacitor, which is unusual, but then of course the Uniden doesn't either. AN240 IC there, so I expect that coil to be the detector. So I've got a choke there. See if I can bring that light a bit close without it being in the picture. Clearly this is the PA. Got output transistor there, driver transistor there, and we've got 3 adjustable coils there. Oops. I looked at, when I was looking at the first one and there was no microphone, I did dig out the Knight's wiring chart once again, and I found that it was listed. So he must have come across them too. Let's see if we can zoom in that far. And it's there, C. So transmit at the top, receive, common, and audio. So this is transmitting, and I'll put the camera on the test meter, and then you can see what it's doing. And just before I do that, I'll just tell you what it's doing, and the answer is just under 2 watts. And so none of these are labelled, and so it's just a matter of me kind of telling you, and you're looking where they are. So clearly that's the VCO, which we won't touch because I'm not expecting it to be faulty. These are set up by checking the lock detector pin on the IC. If you ever come up against that, it is researchable as a chip rather than as a radio set. So I will go into transmit, And I'll check we're on high power. Oh, we're on low power. Ah. Wow. Okay, 3.8 watts. So there's 5, there's 4, just under. Oh, well, that's not bad. So that's clearly the first transmit one. There. There's the second transmit one. And that's the third transmit one. We're doing all right. Now all I need to do is find my green hexagonal tool. So we're staying at 3.9 watts there. There's one right at the back here. I can't actually see it from where I'm sitting, and I'm actually having to look at the video monitor to see where I'm putting my tool. It might be transmit, and it might not. I'm just going to warm that up with the soldering iron. It's not that it's got wax in it, but it feels like if I try too hard it's going to snap. Okay, so that is probably something to do with it didn't affect the transmitter. I moved it a bit, so it could be to do with the receiver. It could even be doing something to do with filtering, which I'd have to then recheck on the spectrum I'm analysed under the bench. So that's the transmitter, and it's doing 3.8, 3.9 watts, which is fair enough. It's slightly low on frequency. I can switch to another camera and show you that. So it should be on 27.79125. It's 27.79105. That is well within acceptable limits. It's hardly out at all. It has dropped slightly. We don't need to start messing about with that or replacing it or changing the circuit. That's quite okay. I don't like sets that don't have adjustable reference crystals, but that's just how some are. So we've now got 3 presets to fiddle with in trying to find what we're looking for. Did I say 3? Yes. We've got 6 in total. So I'm going to be looking for low power, for deviation, and for RF meter whilst we're on transmit. Let's see if we can find deviation. Wallow. Wallow. So 2.5 is there. Wallow. We're looking at about 1.2, 1.3. So let's see whether we can find that. I'll put my oscillator on it, which is so much easier to do and more repeatable. And we'll twiddle till we find it. It's going to be, I think, one of those two. It's not that one. It's not that one. It's not that one. Well, these I'd have thought were on the receiver. Well, would you believe that? And that is maximum, and it was on maximum. So it's the one there on the right. How bizarre. Wallow. We can just manage 2. So it's a bit low. So it's one of those you talk closely into. So I'll make a note now on the layout that is deviation. And I've labelled these TX1, 2, 3, 4, 5 and 6. We don't know the coil number because there's no screen printing. So we'll pop the other camera off, we don't need that anymore. So let's see if we can find the RF meter. So it bangs right across when I do that. What about that one there? Nope. It's that one. So we'll have that. We'll have that reading 4, which it now does on the meter. And now we'll look for low power. So switch the radio to low power, and I will put that camera back on. So on low power at the moment we're doing just under 2 watts. So is it that one over there? No. No. I'll just make a note that the which one was low power before I forget. Sorry, which one was RF meter. Trusting, of course, it is adjustable. Well, the answer is it's none of those. So that means it's either the low power setting arrangement is either faulty or there isn't one, but it's wrong at 2 watts, which would be unusual for it to be that far out if it wasn't adjustable. So we'll move forwards and we'll go on to the receiver. Well, it's receiving right now and we're listening to 0.3 of a microvolt. So let's have a look at the receiver, see how we can put the cyanide meter on, and I'll put the camera onto that. Now this radio is very quiet into the instrument speaker. I've had to turn up the gain on the oscilloscope. Whether it is on its own speaker or whether it's because the detector is out. So just before we go into the receiver sensitivity settings, we'll just do the detector, which I think is going to be that one there, but I could be wrong. Like I could be wrong. Well, if that's not the case, then it must be this one here. It's you know, it's all guesswork, but at least I can put it back right. How strange. So it does appear to be this one. It doesn't seem as snappy action as usual. But that's maximum. So I'll make a note on the chart. Detector. And now we'll go through the receiver. So we'll try and get the meter down to a bit lower than that, and then we can see the benefit of the tuning. It sounds pretty awful. No, that's because I'd upset that one. So we'll unupset a few of these. I want to push that out of the way. Don't want to approach it on an angle. I will just see what that one, whether that affects receive. That one in the behind the transmitter shielding, and the answer is yes, it does. So I'm having to be very careful with this one, not wanting to break it. I managed to get the stuck core out. And put it back in. So that's worked my way up through all the coils, and all of them are to do with receive. Now we need to see why there's such a low output. And the answer is there isn't a low output when you connect the speaker with two wires. I normally expect the earth to go through the test equipment, but on this radio it seems to be isolated. So there is plenty of volume, and that's working exceptionally well, to be honest. So let's see if we can find the S meter. I've got nothing reading on there at the moment. Oh, no, we've got full scale deflection. That's why I couldn't see it. So that needs to come down. So is it, because that was the transmit meter, is that the receive meter? And the answer is yes, it is. So we'll get that to 9 like that. And we'll make a note on our chart. So it's S meter. So RX1, RX2, RX3, RX4, RX5, RX6, RX7, RX8. There's a lot of them. So another one is going to be squelch. So let's see how the squelch is performing. So we'll turn the signal generator off and set the squelch to threshold. Switch the generator back on. So we're now down to a choice of 3. It's not that one. And it's not that one. It doesn't look like that one, so we'll have to try it another way. That one, and I'll just pick my clipboard up off the floor. So there we are. So we'll set that up. So signal generator off. And squelch. So that comes on sensibly. Let's put the squelch to full. It comes on at S9. It's absolutely ideal. So that was easy to set. Done. Well, that leaves us with 2 others. Now, we never did get to the bottom of low power, so I'll just pause the video and see if I can get to the bottom of these 2. Okay, so it's still a mystery. Could that be mic gain? I've kind of had a play around, but I can't make it change, so question mark. Question mark. I really don't know. Well, I've set them to midway, and the radio is working well, and the only thing I can't set is low power. So all I can say about low power is I've looked at the wiring between the switch, and it's 2 white wires go to the switch, follow the white wires round, and it goes to a couple of resistors there in the driver's section of the transmitter, and there's nothing adjustable in there, so one of those mystery controls is not low power, and the fact it's doing just under 2 watts, something's not being calculated right for that to happen. But it doesn't matter, it's not a requirement these days, so we'll leave it as it is. It's 4 watts on high power and it's 2 watts on low. And it's been put in as an afterthought, that. So, you know, I don't think there's anything else we can say about it. I'll put it on the... Oh, this is a busy light instead of a receive light. Let's just turn the signal generator off. So you see, when it receives a signal, you get the busy light rather than... Bit like the Murphy does that, doesn't it? Anyway, I'm going to put it together. So I have come to a conclusion on this one. That is squelch, and that is IF gain. So there we are. So that leaves us with 1 mystery control. Okay, so we've popped it on the aerial. Right, well, I'll just try it, you never know. 19, Roger. Anyway, we'll do a scratchy corner test with Mr Chippie later on. And I'd be interested to know whether any of you have ever had a Eurocomm 40. And as you saw, I do have 2 of them, but I can see the other one's going to be kind of scrap box material, but you never know, another scrap one might come along with the missing part. It's that heatsink which is the killer and stops us from really doing that. But we could have mackled something together if we hadn't have had this one. There you have it, the Eurocomm 40 from 1981, which at the time was £69.